Hello and welcome back. In this session, we are going to learn valid parentheses. That means we are going to check whether a given set of parentheses are valid or not based on mathematical rules. So let's check the problem statement here. In line number 5, maximizing it so that we can read it well. Okay. Okay, here is the problem statement. Given a string containing only the characters open parentheses, close parentheses, open curly brace, close curly brace, open big square bracket, close square bracket, determine if the given string is valid. A given input string is valid if open brackets are closed by the same type of brackets. Open brackets are closed in the correct order following the traditional rules of mathematics. Okay, so basically we are checking whether all set of brackets, a string containing all the brackets, they actually form valid mathematical structure or not. Okay, for example, we have sample input 1 that has open and close parentheses, which is a valid input, right? So it's written true. And then the next in line number 14 we have open parenthesis and then a square bracket which is closed by the closed parenthesis. That's not right, right? It should have been closed by, it would have been okay if I have open parenthesis and then opening and closing a square bracket and then closing parenthesis. That's fine actually, but it's not valid, so we return false. So algorithm, what we do is we traverse through the given string, and then if it's opening stuff we store, and then if it's closing we just pop, and then we match with the current character, and if it is matching, then we kind of continue and see other items. If it's not matching we return false, and then at the end of all comparison, if the stack is empty, that means we had all the matching pairs. If it's not empty, then we return false. Okay, so in terms of time complexity, we traverse through the given string one by one. So it's order of n time complexity, and popping, pushing, it's constant order of 1. So time complexity order of n, and in terms of space we just stack, and in the worst case we have to, or in the worst case in the given string it might have all the open parentheses, right? I mean all the open uh, characters, all are brackets, some sort of brackets, open parentheses, open curly brace, open square bracket, right? So all of them all open only, no close. That's the worst case. So in that case we'll be all pushing, so that means we'll need a stack of that couple of storing n elements. That means uh, space complexity is order of n in the worst case, right? And time complexity is order of n. So that's the solution that we are going to implement, and we are going to first implement in the we are going to first implement in Java. Okay, minimizing this one so that we can start typing program. Okay, let's start our file. Vi, our familiar friendly editor vi, valid parent.java. Okay, I'm going to type. Okay, so my class is called valid parent. Okay, and then I'm going to start my usual friend public static void main driver code here. Okay, and I'm going to do that a little bit later because I want to first implement my core logic. Okay, static boolean is valid, and I'm going to pass two things. One is hash map of character. We'll see shortly why we need that, and I call that mappings, and string of given expression. Okay, all right, we're going to implement here. Okay, and let's activate line numbers 2. Okay, now okay, in the first we create a stack because we're making use of a stack, and we'll have to import it. Stack character, call it a stack, new stack. Okay, within and this one, and if I'm doing that, what I am supposed to do is I have to import java util, and that's where the stack is available. Okay, you might need to import some other items too, but we'll come back there. And okay, our stack is created. Now I can do my main looping. Int I is equal to 0, I is less than dot length, this one, and I plus plus, and I need to do that. I need to do that for all the elements. Let's have a length there. Okay, so okay, current character. I want to get current character because as I'm traversing through the string, I'm processing that. First I'm going to get the current character. Okay, ith character basically. Expression dot caret I. Okay, that gives me the current character. And what do I do with that character? I do this thing. If I check something, what is that something? If mappings contains key, okay, current character, okay, and if that is the case, then what do I do is I pop it. Yeah, this is the case where this is the case of closing parenthesis. If that's the one, I pop it. Okay, char top element. Yeah, main logic is if it's a closing parenthesis, you pop it. If it's a opening kind of brackets, if it's a closing bracket, you pop it. If it's a opening bracket, you just push it to the stack. Okay, and as soon as we get closing, we check whether there is a corresponding opening or not. Right? That's how we match the pair. So char top element, we pop here. We check whether stack is empty or not. Empty. Okay, we check that. And if it's empty, then we just return some dummy character. If it's not empty, and we just pop it. Okay, that's it. And okay, if that is now, yeah, as soon as we let's do one thing. Okay, in that if, okay, we pop it, and in the same if, let's do something here when we remember it. If it's a closing parenthesis, then that contains key char mappings to contains key, that tells us if it's closing or not. Okay, otherwise what do we do is we push to the stack. Okay, and we need to do a little bit more here. Once we pop, we check something. If top element is not equal to mappings dot the thing that we popped is not equal to mappings dot get current character. Okay, current character. Top element is not equal to mapping dot current character. Then what we do is, that means it's not matching. If it's not matching, then basically we know that there are no matching pairs. Okay, so we return a false. And there is another case where it's also, that also tells us it's not matching, and that is after we complete the for loop. Okay, after we complete the for loop, which is this one, and we do that right here. Return stack is empty. Yeah, basically what it's telling is, if stack is empty, that means it's valid. That means there are matching pair. If the stack is not empty, that means it is not matching because something is left there. Okay, so that is basically the complete logic, but we still need to write our driver code. Okay, and here is our driver code. I need hash map. Okay, I need something like hash map character mappings. Actually, I could do it in the same line, but it's going to be long. That's why I'm going to make use of 2 lines. Is equal to new hash map character. Yeah, actually, I didn't have to necessarily write this one. You know, it should be only this much, right? So now I just store my mappings. I have 3 things: mappings dot put. Okay, so what am I putting is, for this one, for this closing parenthesis, there is a opening parenthesis, right? And similarly for this closing curly brace, I have opening curly bracket, and last one is mappings put for closing square brackets. We have opening square bracket, and next thing we're going to do is we're going to define let's just call it, that's fine, expression 1 is equal to, this is valid, this is valid one, and we know that from our knowledge of mathematics. Boolean result 1 is equal to is valid. Mappings, I need to pass that by expression 1 system.out.println and result 1. Okay, and then there is we'll do one more. Okay, expression 2 will give something interesting that looks like valid but is not valid. Okay, we will closing the square bracket with parenthesis, and then we have a square bracket later, so this is clearly not valid in mathematics. Boolean result 2 is equal to is valid, and again we put mappings and my expr2. Okay, and we print that. Out.println result 2. So everything is right. Everything okay. First we will compile and check if there is compilation errors. Fix that, and then we'll run it. Java-C valid parent.java. Oh, there are so many. There are so many. Okay, why so? 30 errors. That's a very large number. Let's check. Okay, one thing that I remember is I forgot something. See, hash map. We need to import that. Let's do that first. Dot hash map. Okay, it should certainly decrease. Okay, 30 from 30. Oh, we still have 30. That's a lot. Okay, I'm going back. Yeah, we have a lot to fix now. Alright, hash map import Java util, that's okay. Valid parent, do we have parenthesis correct? Do we have parenthesis correct? Let's say that. Okay, looks like it is. But mappings, new hash map, mapping. Let me try this thing. Let me try that. And see. Oh, that actually should not make a difference, but anyway, it reduced one, but not sure what got reduced. I think that probably is not the reason. Okay, I think so. 29, yes. Class interface item expected. Okay, let's see. I think there is some problem with, let's see, class valid parent. Okay, let's see, brackets. I'm thinking brackets may not be matching. Class public static void MAIN string arts. Okay, MAIN. Okay, for this, let's see, that is matching. That one is for 4, and that one is for else of receive, and we have if here. That looks like matching. Put mapping start put comma close this expression one. Okay, one more time. I'm going back and recompiling it. Let's see from the first one. Illegal dot. Oh, yeah. Did you see that? That one dot is going to create a big 29 errors. Okay, now let's do it. This will certainly decrease 4 errors from 29. That one dot, you have only 4 errors, right? No suitable method found for put string a string. Okay, that is very correct. Sorry, that was a missed command. Yeah, we define it to be character, so it has to be single quote, and we're going to correct this, and this one as well, this one as well, this one as well, and this one as well, this one, this one, and this one. Okay, now there is something left. Mappings put, yeah, let's go back. Okay, again, that one. Yep. Okay, let need parentheses there. Compile. Hash map is spelling mistake. Hash map, which line was it? Over here. Over here. Hash map. Okay. Right. Compile one more time. Compile. So let's go back to the program one more time and see. The first is correct, the second is incorrect. So we're expecting true and false. Okay, so we already compile. So we run it. How do you run this? Like this, we expect true and false. That is exactly correct. All right, so we are done with Java implementation. In the next video, we are going to do Python implementation.